Okay, we have another question. We are still on the premium of suspended laminae. So we are going to handle this, then we see what happens. So the figure below shows a composite. I think now we know what a composite is from previous lessons. In a rectangle, of a rectangle and a triangle, as you see, a triangle and a rectangle. Find the center of gravity of the composite from AB and AE. If the composite is to be suspended from C, find the angle BC makes with a vertical and horizontal. So what we do, to get the center, we need to know I'm going to call this one area 2 and I call this area 1. So to get the center of gravity, we need the weight. But how do you get the weight if they are giving us these figures? We first get the area, then multiply by weight per unit area. So we don't know the weight per unit area, that's why we say let W be the weight per unit area. So now that calls for get the area of these two first. After we will determine their weight. After determining their weight, we will find where that weight of these two is acting. So the weight of this will act somewhere and the weight of this will act somewhere. As simple as that. So first of all, area 1 is a rectangle, which is length times width, which is going to be 120. So now my weight, to get weight of the first lamina, this one, we get this now times the weight by unit meter, which we say is W, so it will be 120 W, as simple as that. Then to get area 2, our area 2 is a triangle. Our area 2 is a triangle, which is a half times the base from here to here, is the same as times there, which is times then 9. The height from here to here, I think you see it's going to be 9. So they are telling us that this is 9 centimeters up there. So this is going to give me, this is going to be 6 times 9, that will be 54 centimeters squared. So it means that now my weight 2 is going to be, I get this, the area times the weight per unit. 54, that will be as simple as that. Now after that, so this is the weight of this and this is the weight of this. Now to get the weight of the total composite, I add this plus this. So my total weight, which is going to be 120 W plus 54 W. So this is going to give us 174 W. If that is hard to get a calculator and press it, don't worry, because once you make a mistake here, you are going. That's why even if there's some question, even if some are easy, I get a calculator and I press to show you. Okay, so after getting this now, we come and determine. Now we have the weight for this and we have the weight for this. Now we want the weight where this one is acting, the whole of this one, the weight where this one is acting. So we get the center of gravity for this and the center of gravity for this. So then we call this one B1. The center of gravity for this first one, B1. Where is it going to be? You see, this one is going to be, we are getting them from AB and AE. So this is AE. So from AE to this center of gravity of this rectangle is going to be, because this is 12, center of gravity of a rectangle is always in the middle. So now, from here up to here, this is the same as from here up to here, halfway. So this is going to be now 6, comma. Then from AB to this, you see this is 10, meaning this is going to be 5. So here, our weight 1 is going to be acting from there. Then I come and I get also the center of gravity for the second one. I'm going to say it's going to be there. The B2. The B2 there. So to get the B2 now, you see, and then also from AE. AE from here up to here is the same as from here up to here. So that's going to be from here up to here, which is also 6, comma. Then I need the from here up to here. First of all, we need to determine this length from here up to here. And we are going to use this idea for a rectangle. From the vertex is 2/3 h of the height. Then from the base it's h/3, also a part of h. So determine this distance here, just determine the distance from here up to here. So from here up to there is going to be h/3, which is going to give us 3 centimeters. Now we need to determine from here up here, because they want us to get from AB. So from AB up to this, we get now the 10 up here, we add this to 3, which will give us now 13. The whole from here now up to there, that center. Those are that's how we're getting our 13 centimeters. From here up there, we are getting our 13. So our weight now, our weight is going to be acting here. Our weight W2 is acting because this is the center of gravity of this weight down. I mean of this triangle, and this weight is this, so it's acting there. So after getting that, the rest are very easy to determine. The idea, whenever I say triangle, know from the vertex to the center of gravity of that triangle is 2/3 of the height. Then from the base to the, if you want the base, from the base, like in this case, there's no we cannot use this because we are our AB is below the center of gravity, as simple as that. So there our center of gravity, X bar, Y bar. It's going to be W1 into X1, where we need the weight and where it's acting. We know W1 is acting here, and the coordinate, we know it. We also know W2, where it's acting, X2, Y2, over the sum of those two, W1 plus W2. Simple as that. So from here, my X bar, Y bar is going to be my first weight. Weight 1 is 120 W into, where is this weight acting? It's acting at 6.5. Then plus my W2, which is 54 W acting at, where is W2 acting? It's acting at 613. Then the whole over the sum of these two. When we add these two weights, we got 174 W, and this side W is common, which you can easily cancel. And then when you simplify this onto the calculator and you get the upper thing there. Okay, so my first here, when I get this one, I simplify, I get 1044. Then this one down, I'm getting 1302. Of course, we are dividing with 174, which when you get and we divide, we shall get 144 over 174, then 1302 over 174 with ease. So here our X bar, Y bar is going to be, when we simplify that, so here I'm getting 7.5. I'm giving to one decimal place. Then I simplify the upper. I'm getting 6. So now therefore, our center of gravity is at, of course these are centimeters, 6, 7.5 centimeters from AB and AE. From AB and AE as our axis, then that will be our answer there. Okay, then in part B, then we come, they want us to get the angle. If they want us to get the angle, then we draw this, and then we time. Now we know where the center of gravity is. It is at 7.5, then 6. So we come and we draw it here. We draw that shape just for is this. So we'll see what we are going to do. This is our so that's now the case. This is our A, B, C, D, E. Okay, now our center of gravity, we've seen that our center of gravity is 6 and 7.5. So remember the whole from here up here we have the 12 centimeters up here. Then up from here up here we have 10 centimeters up to there. Now our center of gravity is at 6 Since that is going to be in the middle, so it's in the middle, and 7.5. It's going to be somewhere here. So this is where we have our B, which is 6.7.5. That's where our B is. Now, yeah, let me write it the other way, so because so this is where our center of gravity is going to be. So it's at B, 6.7.5. Now, they want us to get the center. If now they are asking us to get the angle because they are going to suspend it at C. Now, if they are suspended at C, it means that now the particle is going to come from the point of suspension through the center of gravity. So they are suspending it at C. At C, and then they want us to get the angle. The vertical makes it horizontal. But the question is, how do we do the vertical? The vertical is always from the point of suspension through the center of gravity of the wall. So the whole thing here is center of gravity is here. So now, to get a vertical, I go from the point of suspension through the center of gravity as you see there. So now this one will be my vertical. So this one is going to be now my vertical. How do we do the horizontal? You say the horizontal is perpendicular to this. So it's going to be perpendicular. So you see, for it to be perpendicular, it means that it has to be in this order. So this is going to be my horizontal. This is perpendicular to the vertical. So this is my horizontal. Horizontal. So now the angle it makes with B, this is going to be the angle to make with BC, which is theta. So this is the vertical, this is the horizontal. What do you know? Always the vertical passes through the point of suspension and through the center of gravity, as simple as that. So we want this now. This is the triangle one. So we want the height from here up to here, then we want this. But because they are from now, they are telling us that this is what we want here. We want to use this triangle here. So we need it opposite over that there's now. They said it from here up to here because they said it from AB. So meaning this distance from here up to here is known. So this distance from here up to here is known as what? From AB up to here, the vertical distance is 7.5 centimeters. Then from here up to here, we know that the distance from here is going to be 6 centimeters up to there. So meaning, if you want to get the remaining distance from here up to here, we can calculate, because from here up to here, we can also calculate. So if from here up to here is 6, it means that now the remaining distance here is also going to be 6 centimeters. If this is 6, then mean that also this one is going to be 6. Then if from here up to here is 10, and now from here up to here is 7.5, what's the distance here? The distance is going to be 2.5. So from here up to here is 7.5 centimeters up there. Mean now from here up to here is going to be 2.5 centimeters. So if I pick out that triangle there, this is the case now we have there. That is the case I have. So this is my theta. This is my... So this is going to be from here up to here. From here up to here, it's going to be 6 centimeters. Then from here up to here. From here up to here. I did this from here up to here because it should be from here up to here, which is 2.5 centimeters. So now that we can see, we are going to use our tan theta, which is going to be the opposite, which is going to be 6 over that adjacent 2.5. And so my theta is going to be here I'm getting 67.38 degrees. Theta. Now this is the one for the vertical. Then for the horizontal, let me call it this. Now if this is, we want the one with BC makes it horizontal, let me call it alpha. So if you put our alpha here, alpha. already know that. BC, okay, angle, BC, mix with horizontal, then there you see, it's going to be, see that this is perpendicular. So, it means that when I add this theta and alpha, I get 90 degrees. So, meaning that now my alpha is going to be 90 minus, which is giving me 22.62 degrees. So, this is the angle ABC next with horizontal, this angle here. I'm calling alpha. That angle alpha there. So this is the horizontal, this is the vertical. Once you know those ones, the rest are going to be always easier. Let me make it here so that it's pronounced. This is the horizontal there. Okay, so always the point is that the vertical is always from the point of suspension through the center of gravity. Then after that, the rest are going to be very easy. So that's it, members. I wish you well.